let's see the next question. For the function f of x is equal to minus 2 in the region minus pi comma 0 and 2 in the region 0 comma pi, the value of an, here an is the coefficient of cos nx, in the Fourier expansion of f of x is 2, 4, 0 or minus 2. So this question is from Fourier series. Okay, for any given for any questions in Fourier series, when you have to find out the coefficients of cos nx or sin nx, or if the question is about finding the constant in the Fourier expansion of the given function, the first thing that you should remember, the first important thing that you should remember is whether the given function is odd function or an even function, because we know in a Fourier series expansion of any given function, if the given function is even function, the Fourier series expansion does not contain, if the Fourier series of a even function does not contain sin x, it only contains cos terms, sin terms rather, okay? It does not contain sin terms. It contains only cos terms and constant terms. Similarly, if it is odd function, it contains only sin terms. It does not contain cos terms and it does not contain constant. If you see, the given function is f of x is equal to minus 2 in the region minus pi comma 0 and plus 2 in the region 0 comma pi. First check whether the given function is odd function or even function. How to check whether a given function is odd or even function? The definition for even or odd is if f of x is equal to f of minus x. So in the given function, if you substitute x or minus x, if the value did not change, then this is even function. If you substitute minus x and the value is negative of f of x, so f of x is equal to negative minus of f of minus x, then the given function is said to be odd function. The given function is said to be even when f of x is equal to f of minus x. It is said to be odd when f of x is equal to minus of f of minus x. So let us do the same thing. F of x is equal to minus pi in the range of minus pi comma 0, it is equal to minus 2, and in the range of 0 comma pi, it is equal to plus 2. So, in between 0 to minus pi, let us take one value. Pi is actually approximately 3.2. So, let us take some minus 2. Okay. So, what is f of minus 2? To check this one, I am just taking some value in the given interval. I am just taking between 0 comma pi or 0 comma minus pi, some value. Pi is approximately 3.14 something. So I am taking some value minus 2 in between. So what is f of minus 2? It falls in this region. So the value is equal to minus 2. Okay. Now find out the negative of this one. So f of 2. What will be f of 2? 2 falls in this region. So the value is 2. So this is nothing but negative of this. So negative of minus 2. That is nothing but negative of f of minus 2. So f of 2 is negative of f of minus 2. So this satisfies this odd definition of odd function. F of x is equal to minus of f of minus x. F of 2 is equal to minus of f of minus 2. So the given function is a odd function. Now we know an odd function, expansion of an odd function, Fourier expansion of an odd function contains only sine terms. Okay, it does not contain constant terms as well as cosine terms. But what the question was asked is, what is the coefficient of an? An is nothing but coefficient of cos nx. The cos term, this is an odd function, so there won't be any cos terms in the Fourier expansion of this odd function, so the coefficient will be equal to 0. So the correct option is C here. So instead of evaluating the coefficient by the Euler formula, what we can do is, before going for the formula, just check whether the given function is even function or odd function. In case of even functions, sine terms will be not there, so the coefficient of sine terms will be 0 if the question is coefficient of Bn is equal to, in case of an even function, that will be 0. In case of an odd function, coefficient of cos nx and constant will be 0. So the correct option here is 0. Now, how to check an even function or odd function? You consider a value between in the given interval, then find out what is the f of x and what is the function of f of minus of that value. Then compare those two values. I have taken a value minus 2, which is between 0 and pi. Pi is approximately 3.1, so I have considered 2. So f of 2 is 2, f of minus 2 is minus 2. Minus 2 is nothing but minus of minus. So f of 2 is equal to minus of f of minus 2. This satisfies the definition of odd function. So the given function is a odd function. Odd function will not have constant as well as cosine terms. Here cosine was asked, so it will not have cosine terms. So the coefficient shall be 0. Now, evaluating an even function or odd function can be done in another way also, using the graph of the given function. If you write the graph of the given function, it would look like something like this. How the graph will be? Okay, say suppose this is the values. Now how he has given, say this is 0, this is pi and this is minus pi. Okay, now between minus pi to 0 the value is constant and it is equal to minus 2. Say suppose this is 2, this is minus 2. Here on y-axis usually f of x, on x-axis usually x will be written. So between minus pi to 0 the value is constant, that is minus 2. So minus pi is this 0. So here the value of f of x is constant. So f of x will be represented by a constant horizontal line. Now between 0 to pi f of x is 2. So between 0 to pi, that means in this region the value of the given function is 2. So it will be a constant line like this. So this is the graph. We have already seen during the lectures, during the classroom lectures, an even function will have, what we have read is, an even function will always be symmetric about y-axis. So whatever is there in the first quadrant will be there in the second quadrant, and whatever is the type of graph in the third will be same in the fourth quadrant. So an even function will be symmetric about y-axis, whereas in case of an odd function, the graph will remain same in these two opposite quadrants, 1 and 3 and 2 and 4. So the graph would remain same in 1 and 3 quadrants, 2 and 4 quadrants. If you see in quadrant 1 and quadrant 3 the graph is same, that means the given function is a odd function. So without second thought, without further calculations, you can directly make the, odd function will not have cosine and constant terms. So we have been asked a cosine term coefficient which should be equal to 0. So this will be the correct option. So this is one way of verifying whether the given function is even function or odd function. This is another way of verifying whether the given function is even function and odd function. What is the principle here is, even function will be symmetric about y-axis, whereas odd function will be For odd function, the opposite quadrants, that means odd function, the graph will be same in first and third quadrants, second and fourth quadrants. Okay, that way you can know. Now the standard, apart from these two, the standard way of finding out the coefficients or the Fourier expansion of a given function is you have to make use of the Euler formula. What are the Euler formula? I am just writing in very brief here. What are the Euler formula? If a function f of x in the given interval, given function f of x, the given interval is, say suppose, minus L comma L, or otherwise the given interval is, say suppose, alpha comma alpha plus 2L. Given function is f of x and it is periodic with period 2L. Then what is the value of constant a0? Or rather, I will just write what is the Fourier series form. F of x, Fourier series of f of x can be written as f of x is equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos nx plus bn sin nx. This is the Fourier series of the Fourier expansion of the given function. Whereas Euler formula are there for finding out what is a0, what is an and what is bn. What is that Euler formula? a0 will be equal to 1 by L integral alpha to the given range. Okay, I'll just write here alpha to alpha plus 2L f of x dx. This is the value of a0. Whereas what is the value of an? An is equal to, again same, 1 by L integral alpha to alpha plus 2L. An, here the coefficient is cos nx, so here also it remains the same. F of x cos nx dx. F of x cos nx dx. Whereas in case of a bn, the formula for bn is 1 by L integral same alpha to alpha plus 2L f of x. Bn is the coefficient of sin nx, so f of x sin nx dx. This is the Euler formula. This is the Fourier expansion. These three are the Euler formula. A0 is equal to 1 by L integral alpha to alpha plus 2L f of x dx. An is equal to 1 by L integral alpha to alpha plus 2L f of x into cos nx dx. Bn is equal to 1 by L integral alpha to alpha plus 2L f of x sin nx dx. These three are the Euler formula. Now to find out the value of an, we need to apply this formula. Suppose if we have applied, how we have to calculate, let us just see here quickly. Okay. So we need to find out an. The formula is an is equal to 1 by L. Here L is 2L is the period, so L will be half of the period. Here it is minus pi to pi, so in place of 2L it is 2 pi, so it becomes 1 by pi integral, the limits given is minus pi to pi f of x cos nx dx. Now f of x is defined in minus pi to 0 and 0 to pi differently, so this can be expressed as, I'll just erase all this here. So this integration we can write it as two different integrals, 1 by pi into integral minus pi to 0 f of x cos nx dx. But integral in minus pi to 0, what is the value of f of x? Minus 2. So it becomes minus 2 cos nx dx plus integral 0 to pi f of x dx. Okay, integral 0 to pi, the second interval. In 0 to pi, f of x value is 2. So 2 cos nx dx. Okay. Now, what is the integration here? Integration of cos nx is sin nx. Correct, right? Integration of cos is sin nx by n. So that will be 1 by pi, this whole thing. 1 by pi, minus 2 also you can take out common, minus 2 into integral cos nx is sin nx by n. Between limits minus pi to 0 plus again 2 into sin nx by n between limits 0 to pi. Now 1 by pi into minus 2 into, now the n also I can take out common, sin nx, if you substitute 0 it becomes sin n into 0, that is sin 0, sin 0 is 0, minus sin of minus pi, if you substitute sin of minus n pi, sin n pi is also 0, so this turns out to be 0, plus 2 into, again the same case, sin n pi is 0, minus 0, sin 0 is 0, so the whole value becomes 0. So the correct option is option C. Okay, in general, by following the theory you need to solve it using the Euler formula like this, or otherwise the easiest way is to check whether the given function is even function or odd function. If you can find out the answer by that definition, your time will be saved, or otherwise you need to do it this way, the standard way using theory. So we have seen solution of this by checking whether the given function is even function or odd function. Now let's see how, using the standard theory, how to solve this. Okay, any given function f of x, any given function f of x in a given interval alpha comma alpha plus 2l, what is the Fourier series expansion of this function? What is the Fourier series expansion? F of x can be written as f of x is equal to a naught by 2 plus a naught by 2 plus sigma n is equal to 1 to infinity a n cos n pi x by l plus b n sin n pi x by l. This is the Fourier expansion of a given function in the interval alpha comma alpha plus 2l, whereas 2l is the period of the given function here. Now, how to find out these constants a naught, a n and b n? A naught, the formula for a naught is given by a naught, a n and b n are given by Euler formula. A naught is equal to 1 by l integral alpha to alpha plus 2l f of x dx. Whereas the formula for a n is 1 by l integral alpha to alpha plus 2l f of x cos n pi x by l dx. Here a n is the coefficient of cos n pi x by l, so a n will be equal to 1 by l integral alpha to alpha plus 2l f of x into the same coefficient cos n pi x by l dx. Similarly, b n will be 1 by l integral alpha to alpha plus 2l f of x sin n pi x by l dx. So this is the standard formula what we know. Now in this question what has been asked? The value of an. An is nothing but the coefficient of cos nx, that also he has given. So what will be the value of an? From Euler formula, an is equal to in 1 by L. Here 2L is the period he has given. So what is the total period here? It is minus pi to pi, that is 2 pi. So 2 pi is equal to 2L. So here L is nothing but pi. So 1 by pi integral, the value is, the total period given is, region given is minus pi to plus pi. So integral minus pi to plus pi f of x. F of x is Okay, I'll just write f of x is two different definitions has been given. So let us just write f of x cos n pi x by L. N pi x by L. N pi x by L is again pi. So pi gets cancels dx. Okay. Since f of x has two different definitions. Different definition in minus pi to 0 and a different definition is 0 to pi. So now expand this integral to consider of two different integrals, minus pi to 0 and 0 to pi. So if I do the same thing, this becomes 1 by pi into integral minus pi to 0. In minus pi to 0, what is the value of f of x? Minus 2. So it becomes minus 2 cos nx dx plus integral 0 to pi. In 0 to pi, what is the value of f of x? 2. So it becomes 2 cos nx dx. Now 1 by pi minus 2. What is integral of cos nx dx? Integral of cos nx is sin nx by n. Okay, I'll just write this again, minus 2 I'll take out, so it is sin nx by n between limits minus pi to 0 plus here it is 2 into again cos nx, so sin nx by n between limits 0 to pi. Now if you substitute here 0, if you substitute upper and lower limits, so sin 0 is 0. So this will be equal to, if you further expand it, it becomes 1 by pi into minus 2 into sin 0 is 0 minus pi. If you substitute again it becomes, let me write that, so 1 by pi minus 2 into sin 0 is 0 minus sin of minus n pi. Sin n pi is also 0. So it becomes 0 plus again 2 into sin 0 is again sin pi. Sin n pi is 0. 0 if you substitute also it becomes 0. So totally this became 0. So we will get the same answer C. Okay. So we need to do this much of a calculation to get the actual value. Suppose if you can guess that the given function is a odd function. In odd function there won't be any cosine terms, there won't be any constant, only sine terms will be there. So the coefficient of cos nx shall be 0. We can directly deduce the fact by the fact that the given function is a odd function. Let's see the next question. The solution of the PDE dou square u by dou x square is equal to 9 into dou square u by dou y square is. 4 options were given. So the question asked is about solution of a differential equation. Remember, if the given question is, we need to find out solution of a given differential equation. It may be ordinary differential equation or partial differential equation. One of the best method is to substitute the given options in the equation and find out which of the options satisfies the given differential equation. This usually is the best method in competitive exams such as engineering service examination prelims or GATE. The other method is more standard method where you know different from the theory different methods possible to solve a given differential equation. That will be a slightly lengthier, particularly for keeping in view the competitive exams. The best option is to substitute the given options and find out which is the best option. Now let us substitute, suppose option A, sin 3x minus y. For that we need to find out what is its first second derivative and with respect to x and second derivative with respect to y. Now let us find out, let us treat this as u. So what is its first derivative? I will write it as ux, u suffix x. First derivative will be sin 3x minus y becomes cos 3x minus y into first derivative of derivation of 3x minus y with respect to x. Derivation of 3x with respect to x is 3, with respect to derivation of y with respect to x is 0. So first derivative is 3 cos 3x minus y. How did I write 3 here? That is from the chain rule. What chain rule says? Derivation of f of x we know is f dash of x. derivation of f of g of x in place of x, if there is any other function is there, then the derivation will be equal to f dash of g of x into g dash of x. Means derivation of the inside function. The same I have applied here. Sine derivative is cos. This derivative I have written it here. 3x minus y derivation with respect to x is 3. Similarly, again next derivation, one more time, second derivative with respect to x is cos becomes minus sine 3x minus y. That minus into minus 3 it becomes into, again derivation of the inside function with respect to x is 3. That 3 into already existing 3 becomes minus 9. Okay, now what is the derivation with respect to y? Sine again becomes cos 3x minus y into derivation of this with respect to y, partial derivation, so this becomes 0, this becomes minus 1, so it becomes minus cos 3x minus y. What is the second differentiation? Partially with respect to y, minus cos becomes minus sine 3x minus y into again differentiation of this with respect to y, it becomes minus 1, so again one more minus. Minus into one more minus, that is minus 1. Okay, let me write it here. Minus 1. So minus 1 minus becomes positive and again becomes negative. So this is negative sine 3x minus y. So if you compare these three, this I can write it as 9 into minus sine 3x minus y. Minus sine 3x minus y is nothing but uyy. So 9uyy. So uxx is equal to 9uyy. So uxx is equal to 9uyy. So option A is the correct option. This satisfies the given differential equation. So the correct option is option A. For your verification, you can also substitute B, C, D and check whether they satisfy or they does not satisfy. They are not supposed to satisfy, that you can check it. Okay, now one more small tip before while solving any differential equation is that, suppose say the given option is sine 3x minus y is there at option D and this is there at option A. Then your total work time will increase. You will substitute this first, it will not satisfy, then this, it will not satisfy, then this, it will not satisfy, then only you will substitute the last option which is supposed to be correct. Then it would take you more time. Here in this case option A itself is the correct, so my time is saved. In such cases what you can do is that slightly take one or 2 seconds and then observe what is the given differential equation, what may actually satisfy this. Okay, now the given differential equation is uxx is equal to 9 into uyy. Okay, by observing all of these three equations, all of these three options, if you see here, the coefficient of x is 3 but coefficient of y is not equal, they are different. Here twice if you differentiate, there shall be a difference between uxx and uyy by 9. So this may possibly satisfy because the x coefficient is 3, y coefficient is 1. So twice if you differentiate, the x coefficient will have 9 but y coefficient will not have any, there will be some differential between uxx and uyy. We can expect it by saying this particular function. Similarly, by seeing this function, if you see x coefficient is 3, y coefficient is 3. So if you twice differentiate with respect to x and with respect to y, approximately, possibly the coefficient will remain same. So the differentiation may not come. So this we can outrightly reject it. Okay, but now again we are left with these three. These are very easy to differentiate and you can check it. 3x square, first derivation. Okay, these are very easy to do. Okay, so we were left with these three. So either now you can actually, 4 options were reduced to 3. Now you can start with this. Then you can find out. So the idea is that observe the given differential equation, and then if something can be eliminated outrightly, so no need to do that. You eliminate that outrightly, completely. Then you start substituting the remaining 3 options into the given differential equation.